Hello, everyone. Thank you for joining. We'll just wait a couple of minutes for remaining folks to join. Can you hear me clearly? It's good. Okay, so I think we can start now. So hello, everyone. I'm Sondos Omar. You've probably talked before through emails or you've had previous communications. For those who don't know, um, work integrated learning coordinator. Um, and I'm happy to be here with you today. Thank you for joining. We will be talking about machine learning. So a bit about me. I've worked in machine learning for a few years now. So I've graduated with bachelor's of mechatronics engineering, worked a bit as a site engineer, and then I've decided I want to study AI, and I've studied a graduate diploma in machine learning in AI, and I've worked with Omdana, which is an NGO for developing AI tools to help communities, and I've worked with Dell Technologies as a machine learning engineer. And the funny thing about that is that before working with Dell Technologies, I've had 100 rejections. So when we get rejections, that's normal. It's normal part of the process of getting a job, of getting a placement, of getting into university. That's not the end of the world. I'd have thought, oh, maybe that's normal, like to think, oh, is it about me? Is it that I'm not qualified enough? Is it that I did not work hard enough to get this job? But actually, it might not be any of that. It's just this is not the right fit for you at this moment. But some of the things I was rejected in, I applied in again, and it worked perfectly fine. So I thought of sharing this with you. Currently, I'm working here with TechNL, which I'm utterly grateful for. And also, I'm doing my master's in computer engineering at Memorial University in machine learning, analyzing satellite images. Okay, let's get started. So since I told you about me and where I am from, I'd like you to use the annotate. If you go up, like press on the upper slide bar of Zoom, you should have like the annotate feature, and then please stamp where you are now. I am in St. John's currently, so I'll stamp here. Oh, okay, I can see.
How do we do that, Sondos?
If you go up to the annotate, up in Zoom bar, press on annotate, and then you'd have like on a side panel that has under the pen, there is a stamp on the left. It's okay if you might not be. Okay, I can see some. Okay, someone started drawing, thank you. That's it. Yeah, and I can see one mark here. It's awesome. Thank you, Patrick. Oh, okay. Got some. Thank you. Okay, if you can do this, just type in the chat where are you from. Okay, so since we're all here in Newfoundland, have you ever heard about the Amazon raccoon forest? Maybe not. So let's know what is this. Can you hear it, right? Still audio working? Oh, okay.
No, not working.
Let me try to fix that. Okay. Sorry about that. Okay. Just 1 second. Okay. Should be working now.
Rookie loves to play soccer with his friends,
Can you hear?
collect acorns from the tree. In the Amazon raccoon forest lives Rookie the raccoon and his family. Rookie loves to play soccer with his friends, collect acorns from the trees, swim in the river, and catch fish. But what he loves most is exploring new places and sniffing new smells. Except he's never made it out of the vast forest. Every night, he dreams of seeing exotic places like Times Square and the Golden Gate Bridge. One day, he sees a portal of yellow light, and his curiosity makes him step inside. Suddenly, he's falling through a long tunnel which takes him to Paris. I've never seen anything like it, he says. And then to the Great Barrier Reef and even the South Pole, where he makes some new friends, before visiting the ISS and ultimately the planet Androida, where the locals didn't speak raccoon, which makes him miss the raccoon forest, and especially his family. Rookie quickly finds his way back home. He's so happy to be back with his friends, but also grateful for his adventures. I guess he's not such a rookie anymore.
Yeah. So what we've just watched is a video that's created by AI. The script itself is AI. The video, no editing, video editing skills were needed. It was all by the AI itself. And this is something called zero shot. So we keep we keep listening to the term AI and things like that. So I believe you're curious about the capabilities. So you can go to this link where if you scan this QR code, you can try for yourself. If you entered any text, it would be able to draw whatever you told it to draw now. Like if it's a flying cat, uh, a walking cinnamon roll, whatever you'd like. If you'd like to envision your dream desk or any of that, just go ahead and type in the text box, and then there's generate button where you can do this. Let me, yeah. Yeah, here. Let me paste this in the chat in case you're joining from your mobile or something. Okay. Yeah, click go here and write. Yeah. If it's something that's complete imagining, you can just write the word abstract. Just trying different things. So I was playing with this, and yeah, finally. So what I did is I selected abstracted spreadsheet from the below so that it can imagine things that don't. Okay. This is another thing I did, which is my dream desk. Like it could be by the beach where we have some flowers and things like that. I'm curious what you guys did. So that brings us to what is AI? What is machine learning? What is deep learning? All these terms we keep hearing all the time, and it's pretty confusing, I know, but um, that brings us to try to imagine like if we're living in all in Canada. As we mentioned before, some people are in Lab West on the map, some people are St. John's, but we all are in Canada. So Canada is the big umbrella, which is under the bigger set, which is the whole world or planet Earth as well. So artificial intelligence is the big one that has uh, machine learning and deep learning as subsets of it, which means they have some of the things. They can do the things that artificial intelligence do, but not all the things. So what is artificial intelligence? It's a program that can sense, reason, act, and adapt. Like we do sense like, okay, that's color red, that's a pen, that's a notebook, this is a camera, this is Zoom. So artificial intelligence can recognize things. What about machine learning? Machine learning is the algorithms that try to improve as we give them data. It's more like kids. When you want to teach a child something, you just give it uh, yeah, some information. This is an apple. This is an orange. This is right. This is wrong. So you just give it information or data or enforcements over time, and that's how it learns. There is also deep learning, which is another part of, like a small part of the machine learning, which has something called neurons. You've heard the term neural network probably over the internet. What does that mean? It's similar to how our brains work. If I want to hold this paper, for example, then my mind would say, okay, just extend your arm, hold it, and that's it. Or extend your arm, hold it. But if I have a feedback, which means that the signals travel from my arm back, which means if I'm holding something soft, even if I'm not looking, I wouldn't crush it because neurons go back and forth. That's why it was called neural networks, in the, and these are what deep learning are made of. All right, so what is machine learning again? Like we've just uh, we've just said that it's similar to like think of it as it's a tool. Like how can we teach a robot to play a game without telling it do this and do that? Or how can we just like teach it how to do things or to help us? And I don't need to give it instructions in every move. So machine learning helps us make predictions and make decisions, and it can make this on its own without full supervision from us. I don't have to tell it at every step what to do. If I trained it, it can do it. For example, the weather. So many times, like we just check the weather forecast and it says it's sunny, it's rainy. What is that based on? Maybe so they do have machine learning models that help predict that the with the feedback of some sensors that they have, satellite images, and a lot of previous data. Okay, so what are the types of machine learning? There are 5 popular types. Well, there are 3. The first 3 are the most popular ones. The 2 last one are less popular. We have supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, and self-supervised learning. from the names, you'd think, okay, I might know what that is. So what is supervised learning? It's like learning from a teacher. She tells us this when we were in kindergarten or play school. This is an apple. This is the color red. This is the letter A. So it teaches us by showing us the letter A that she wrote. But if you wrote the letter A yourself, you'd recognize that this is an A. It's the same for computers. You just show it some data, which is labeled. What does label mean? Like having the title to, or the name of what that is. And then it starts learning that if this looks like this is that. If that looks like this, that's a cat, that's a dog, whatever label we pair it with. Examples. What are supervised learning examples? Okay, have you ever got an email in the spam? Why is that? That's because previously people were getting spam emails and they did not know what to do with it. So that's when the email providers decided to, okay, we have enough data, we have enough examples of what a spam email looks like. Usually they say like, oh, I have millions for you. For example, the word millions or the word money or the word transfer. What to look for to classify this as a spam. But if it has an attachment, like a link or something suspicious, so that's one of the things that is used for. Another thing is in real estate, predicting the house prices. When we go buy house every time, or if we looked like renting a room online or anything like that on the marketplace, usually you don't know how that would cost. So it helps realtors or people who want to sell their homes by themselves to predict what house price is that, like the location of the house, if it's accessible near bus station, if it has an ocean view, if it's in a nice neighborhood, the size, if it is it a big mansion with 5 bedrooms, or is it a 1 bedroom or bachelor? That would, like, if I gave it multiple houses that were sold over the past years, then yeah, it would learn what is the price of this, the age of the house, like how old is that house? Was it built 100 years ago? It definitely needs maintenance now. Okay, and now we'll move to the other thing, unsupervised learning. What is unsupervised learning? Imagine you want to go outside and your room looks like this. And mom says, no, you're not going anywhere until the floor is clear. We would have different approaches. Someone might have some slack to just collect the pants together, the shirts together, the books together, and just put them in place. Another person, I'm just in a hurry, just collect everything and dump it under the bed, dump it in the closet, just pretend it didn't exist. Or someone might say, okay, this big pile wouldn't fit in one place, so maybe I need to split it. I'll put some here, in some on the bed, some on the chair, some in this drawer. So there might be a lot of criteria to to do something called clustering, which is how to collect some things with different, based on their place, based on how far they are, based on the space I have. So this is called finding, the definition of this is finding patterns and relationships in unlabeled data without specific output variables. I don't have an output. I don't know where I'm putting this now. I just improvise or trying to organize this as much as I can. Example of that is Netflix. Have you ever like wondered, wow, why is Netflix so good at telling me what to see next? Or Spotify or YouTube. They always say, see what's next, or they just automatically play what's next. And you would always wonder how come they know you so well. Well, it's not like that. It's just that you're grouped with similar group of people, similar interests. For example, um, if I watched Spider-Man and Susan watched Spider-Man, and then Susan after that watched Barbie. So maybe I'd be interested in Barbie. She liked Spider-Man, she watched the whole movie. Don't you ever like talk to your friends and say, "Oh, I watched this, I liked it." So it's the same concept. It does find what is similar between those and it tries to group them, which is in a supervised way. There are so many other things in that, like sometimes you might hear is like similarity matrix or cosine similarity or things like that. It's okay. We're here to try to know what is the concept and behind that and not don't be scared by the names. You're not expected to know all the names, all the algorithms, everything. And it's an evolving field. So don't feel intimidated. Just be patient and be curious. Another type of learning is reinforcement learning. So now we've done three. This is the third one. Okay. Uh, does anyone have any questions? I don't know where is the chat. Okay. Yeah.
Recording in progress.
Okay. Yeah. Okay.
There's a question there, Sondos.
Okay.
Oh, a couple questions now.
Okay. So yeah, the benefit of one type over the other. Okay. So let's go. Is there a benefit of what? I wouldn't say it's a benefit of one over the other. But I would say that they have different use cases. Like sometimes I don't have labels. I don't have, it's not even an option. So that's when we need to find ways to cluster that. I'm trying to, do I have an echo? No? Okay, cool. Yeah, so I need to find ways to handle that. In so many cases, if I have labeled data, then that would be supervised learning. If I don't have that, then I'd use unsupervised learning. If it's a game or something that needs continuous learning, I'd use reinforcement learning. So there isn't one, I'd say one over the other. It depends on the problem itself. What are you trying to solve? What data do you have? What is your desired output? Okay, how do you determine how many nodes layer to put in the network? There isn't a rule to say this number of layers would work on this network, but it's more of a trial and error. Also, there are some papers that would be published in this area previously by previous machine learning engineers or data scientists. You'd find like if it's an image classification problem, they would share what architecture they use, what number of layers. So the easiest approach is trial and error. And then go ahead. Oh. And the other question is, how do you decide which machine learning algorithm to use for a given problem? Also, that depends on the data quality or the data you have. So we have numerical data. Is it numbers? And you're trying, like, if it's a house, you have like the dimensions or the how many rooms you have. These are all numbers. And so you don't need, for example, something that can work with names. If you have names or something like that, that's a bit more complicated. So there's nothing called like if you're doing this, but there are types. Like if you're doing regression, then there are some regression algorithms. If you're doing classification, what is regression? Regression is if I have something like this, like some dots, and I want to connect them. So I'd say, what is the best line to fit that? That's regression. Classification is like, that's cat, that's dog. So depending on the problem I want to solve, is it like I need to have some different classes and have labels for that? Or I want to enter an input and get an output, like for the houses, that would be called a regression program. If you didn't understand the questions, these were very specific, so no worries at all. Let's continue okay, so there is a third type of learning called reinforcement learning. What is reinforcement learning? It's reinforcement. Like if I'm training a puppy or a pet, I want it to do a new trick. What would you do? If it does something good, I give it a treat. So I can do that in an algorithm, that when it does something that I want, I'd encourage it. And if it does something that I don't want it to do, I'd penalize it. And this is called reinforcement learning. One of the examples of the very famous ones, which is the maze. Have you seen robots going through a maze before? So this is a very popular example of reinforcement learning, where they try to walk through a path and determine, is that correct? Is that closed? If that's a closed, then it would have a penalty. If that's an open way, then it would have a reward for doing that. Okay, so now we have our first question. Just to make sure you're, can we have question 1 on the poll? What type of machine learning algorithms requires label data during training? Which one needs the label? Okay. Okay, I can give you some hints. So we've talked about supervised, which means it knows what it would do. So it has some data and knows what a label is, if that's a cat, if that's a dog. And we've talked about unsupervised. Remember the example of the room, and we're just putting things anywhere without any idea where to put them. Reinforcement is usually for games, as we mentioned, like the robots. Right. We're good. Yep. We have 25% of us guessed it correct. It is supervised learning. Unsupervised learning does not need labeled data. It does not need to know where like just as we were just mentioning, the messy room with just putting things randomly anywhere. Not really randomly, like based on a criteria. Like I just said, okay, these are close to each other, these are here, these are big, these are. So we had some sort of criteria. All right. Let's continue. There are two other types, which are semi-supervised learning. What is semi-supervised? It's like having a few answers, like some labels, and then we use them to guess other answers, which are, how do you reward the robot? So you usually reward the robot by, or penalize the robot by having some equations. It's similar to like giving someone one extra mark for doing this or points. So it doesn't understand logic, but it understands numbers. So I can tell it, if this number is bigger, then you're good. If this number is smaller, then you're doing good. So we usually encourage this by setting a target, like, okay, you need to have 0, for example. So if I gave it 1, 2, then that's bad. It wants to go to 0. So it's more of numbers encouragement or reinforcement via equations. Semi-supervised learning. Semi-supervised learning combines, like it from the name, it has supervised and it has unsupervised part. So it's like having a few answers to a test, or having few answers to label data, and then I use them to guess the things that I have no idea about. So I have some labels, but I don't know everything. Like sometimes we have so many images, some of them are labeled and some are not labeled. Like I know, okay, that's a cat, that's a dog, it doesn't look like a cat and it doesn't look like a dog. So it's a new thing that I need to guess. Another type is self-supervised learning. What is self-supervised? It is like learning to complete a puzzle where you're trying to make the puzzle on your own. Like you don't have puzzle pieces, but you're making a puzzle on your own, which is used so many times. Use it every day when you're typing, like, hi, how are, and then you find that it's auto-completing, how are you, and things like that. So it's trying to continue based on similar things, but it's not that it knows that you're going to say this. It's just predicting using self-supervised learning. All right, we have our second question now. Which type of machine learning algorithm learns through trial and error by receiving feedback from its actions? So it tries something and it learns. Oh, I'm getting so much better. Wow. Remember the trial and error, and it receives feedback from its actions if it did something right or wrong. All right. It is reinforcement learning. Most of you have guessed it right. So this is how we can confuse machine learning. This was a very popular joke in machine learning that they gave it some pictures of muffins and dogs that look like muffin because computers don't understand. They don't understand how to see things as we do. They just like turn this picture into pixels, like like pixels, and each pixel would have a number and things like that. So this might be confusing for a computer. Now they are more powerful in this, but yeah, that was quite confusing for machines at the time. Oh, yeah, isn't it cute? It looks like it. It looks edible to me. All right. How does machine learning work? Usually, okay, we kept talking about machine learning, but how does it work? It's like making a cake. There are steps you follow, and you need to mix them, bake them, and see if it tastes good. Or it's like cooking. You just want to make a curry today. So you add some salt, taste it. Does it taste good or not? So it's the same with machine learning. We first collect the data and we process the data. What is data? Or in case I want to know if you're going to pass an exam or not. So I have data like, did you do the assignment? Did you come to class? Did you ask questions when you were in class? Things like that. And if you did your assignments and did good in the assignments, and then you came to classes and you were interacting in class, then it's more likely that you would pass this class, right? If you did not come to class, you did not do any assignments, if you did not do any of that, or did bit and a bit, and then you went to the exam, then that's a bit risky, right? So in the data, so depending on the problem I'm solving, I need data for that. I need to process this data, like if it's yes or no, or if it's a grade in the exam, or things like that. For example, I can have data like your name. Would your name make a difference in knowing if you will pass this test or not? No. If you've got good grades, if you've got uh, in the past tests, if you have done your assignments, if you're doing all this, then if your name is Sondos, that doesn't mean you're going to fail. Or if your name is whatever, that doesn't mean anything is going to happen to you. And then we get to the model. We choose a model and we train it, or we choose multiple models that can do this sort of thing we need to do. And then we train them and choose between them, which takes us to the evaluation. So I evaluate this model. How well did it predict this, or how well did it calculate this or estimate? That's when we do model evaluation. There are so many evaluation metrics for that. I know it can be confusing, but please don't worry. We're just like chatting about, okay, you probably heard those terms before. So we're just like, it's eye-opening to what to look for and how to approach things. Okay, Chesa, is supervised learning, in supervised learning, how do they create a criteria without earlier data? So in unsupervised learning, there are some criteria that can be created without having like previous, oops, sorry, without having previous data. For example, if I have some points, where can I? Okay. If I have some points that are here and others that are here, So it can do what we call it would just collect those as a group because they are close together just by the location, and those as a group they are also close together. And then we have these, so we can check, is this closer to it, the distance, or this is closer? So that's one of the ways they can create a criteria, like what is closer to this. There are so many more criterias. It's like there is a field in machine learning called unsupervised learning, a lot of things. I'm happy to share more resources with you after this. But I hope I made this make some sense. Yeah, yeah, this muffin picture made me hungry too. All right. Okay. So as we were talking, so machine learning works as a step-by-step process. So usually there's something called machine learning lifecycle, which is what comes after what. This one, or sometimes they call it machine learning pipeline. Why do they call it pipeline? Because it's one step after the other. I can't say, okay, I want to do machine learning. Do you have data? So many companies fall in this trend. They're like, okay, we want to have AI. We want to have machine learning. It's interesting, but they don't have data. How can I help with train a model without data? So first thing is having to know what are the data requirements I need for this problem to collect this data. Like if I want to know if a student is going to pass or not, then I need to collect some data about previous students who passed or previous students who need help to be able to predict their coming steps. And then I need to explore this data myself. Does it make sense to me? Is there like something that when it happens, another thing happens? Like, for example, if a student doesn't come to class, does it mean they are always going to get good grades or bad grades? Is there a relationship in that here? We have like, if they are correlated, and then we prepare the data if there are missing values, if like sometimes when we're putting data, we just miss some values, or like when you were doing the survey, you just write anything in that, any weird value. So how to handle that? Then comes the step of what model do I need here? So if I'm doing supervised or unsupervised, that would determine what model do I need, and then how to evaluate this model. And then if it's doing good, then we come to the final part, which is deployment, where we give access to people to try to use this model, or as you can see, like it's already deployed in your email, for example, if is it that is spam or not, to benefit from it. And then as we go, it's not a one job and done. No, we get feedback, we tune the model, and then we do the whole process again. If we have like in the project review, what do we need and things like that. And we have to do the same life cycle again. It's just like the water life cycle. Keeps going. The machine learning life cycle keeps going. So it's interesting that you'd say, okay, I want to make a model. You have to make a model, maintain a model, supervise it all the time. Just like ChatGPT, for example, it keeps evolving. We've got ChatGPT 4.0. They are still exploring. Okay, since someone asked earlier about what model to choose, these are names, don't get discouraged. I spent maybe, I have bad memory with names. Spent like a few months without like knowing what model is called what. So in supervised learning, these models are popular: linear regression, logistic regression, decision trees. If you want to watch these, there are so many resources on the internet. Like you can ask ChatGPT, explain to a 5-year-old what is linear regression. It will explain to you, like in a very basic way, what is that. Another method is if I type linear regression visualization on YouTube to show us how this is or how this works, like with a visual aid or things like that. There is a nice YouTube channel called StatQuest that has all the machine learning videos. It's very popular in machine learning. Okay, so let's not go through the details of these, but yeah, these are popular names of the models that people do use. You've probably heard about GANs a lot, which is what we just saw the video in the very beginning. Okay, what do you think are applications of machine learning? You can scan this code and share with us what do you think are applications of machine learning. It would appear here. Or you can go to menti.com. Yeah, you can go to menti.com and use this code.
I can't see that code. Can you type it in the chat?
Sure. Site. You go to menti.com.
Maybe you can explain the question again, Sondos?
Yeah, so what are the applications of machine learning? Like what is it used for, or do you think what are the uses of that? I'm afraid this is not updating because I tried to fill it myself and it did not show here. Oh, it is working here. Let me share the screen. Okay. You can see this, right? Okay, application dynamic. Healthcare, yeah, it's used in healthcare. What else is it used for? Do you think you use it while studying? What are uses? Cars, robots, what? Predicting, organizing, yes. In energy, it's used in energy, that's correct. Self-driving cars, exactly. Image recognition, that's also, yeah, can recognize images. Yeah. Yes. It's used in media, creating content for the media, problem solving, helps a lot in problem solving, how to optimize things. Google search results, yes. All right, that's awesome. Oh, it's updated now. Let's move to the next slide here. Yes, helping people fly planes, yes, there, and drones and a lot of things. I love that, yes. So now AI is used in everything. Healthcare, like scanning, your scans are analyzed by AI as well. In classifying whether this person has this disease or not, used in a lot of things. It's not just like by programmers now or by people. It's now everything. Like even in driving, you have auto park, you have auto self-driving. So whatever the field you're working in, you need to use AI. I think, yeah. Andrew was just talking about that yesterday. Everyone is talking about it. You need to know how to use it in your own field. Some of the applications of AI is like image and speech recognition, as we said, natural language processing, which is sometimes like you just typed in the very beginning to this thing to do or to draw something, and it drew it to just based on what you said. Use it in translation, use it in autocorrection, things like that. Medical diagnosis, which is how to know if this person has got sick, if he's good. It's also used in a recommender system, which is Netflix and Spotify. Used in financial. Sometimes when you do an online purchase, your bank doesn't let it go because it might detect it's fraud. Your credit score, the what is a fraud? Autonomous vehicles, self-driving cars that we were just talking about, robotics in gaming. Sometimes you just play with a bot and it wins. Sometimes there are some ethics in machine learning that we need to have. Fairness and justice. We need the models to be designed to be fair. If I design this model here, then it's just trained on people who are living in St. John's, living by the ocean or something like that. Then I'm not taking into account people who are living far away. I'm not taking in account, like, if I just said, oh, the cold is so harsh here that the cold have an effect on people, but like in other areas, they don't have this cold. So it needs to know how to be fair. If we're talking about tech, for example, how many females are there? So if there are less people who are not accounted or trained on, that causes biasing. If you don't see this, you would be biased as a person. So what about a model? If it's not exposed to something, it's gonna have a bias. Transparency. I cannot just give a prediction and say, okay, it's that. There's, we need to have an explainable or reason why is that happening. Privacy. Am I using data I have the right to use? Are people safe when they are using this machine learning thing? Or like one of the incidents that happened, and please be careful. Don't just, if you're doing training, working in a company or whatever, don't copy the company's data and give it to ChatGPT. No, that's a privacy breach. You are responsible for this. Don't give your data to models. Don't give your data anywhere without permission. So that's something very, very important to know. Accountability. Does it take responsibility for their action? We've seen cars making accidents on autopilot, so that's important as well. Bias, how to avoid bias. Sometimes we can, sometimes we can't. Like if we're classifying a disease, so we really want people to have this disease. So I I can't avoid the bias that this percentage of people have cancer. That's something I can't avoid, and I don't want more people to have disease for me to train my model at all. So there would be bias, definitely. There are some challenges in machine learning other than that, like the data quality. Do I have the data? Is it underfitting? Is it overfitting? All of that. That's important to account for. What does overfitting mean? It means like if I'm trained or I practice the new dance, for example, it's that move. If I train too much, it will be too robotic that I can't do something else. Like I can't generalize it. So it's how much you train. Too much of a thing is bad. So it can overfit, can underfit. Like I didn't train enough for this show or for this dance, and I just go do something horrible. I think we're over time here. Sorry about that. Thank you for staying with me. I've had a small experiment for you to do uh, with playground on TensorFlow. I don't know if you have time to do it. You can just like play with it, and see how neural networks work. Not that's totally understandable. We're a bit over the time, and yeah, but I can thank you. And any questions for those who would like to go and let me do the TensorFlow. That's how it looks like. So there are some data sets where you can use. This is visualization of what layers can do, because we've had the question about are we going to do, yes, Patrick, we're going to have more meetings. Right, so for example, when it starts, it doesn't know, so it has two things. Oh, let me just stop. So this is trying to classify. What it does is it starts, let me refresh again. So now if you can look here, well, you can see my cursor like this. Yeah, so here it's just one area. If I press play, it starts to try to classify these to two classes. There are some more problems where we can do something like this, as you can see, because it's simpler. All right, you can play with that. If you have any questions, please feel free to reach out to me. And thank you.
Thank you, Sondos. Thanks to everyone for joining. If you are in our cohort, or if you are someone who applied to the program and want to know more about any topic in tech, send us an email. You can just send, you can sell Sondos. I'm going to put your email in there. You should have already gotten something from her anyway. But if you have topics that you'd like to suggest we cover, or we invite people to come on, please just let us know. And I encourage you all to go and look at some tech ML companies that use machine learning or AI, because there's a lot around that you might not know about. But thanks everybody for joining.
Thank you. Thanks, everyone.
Do you want me to end the session, Sondos?
Please.
Okay, bye.
Bye.